Hello, good morning. How you doing?
Good. How about yourself?
All right, all right. I see too many people logged in. As everybody had this morning. Okay, there go a compliment. There we go. Few more. I guess we could get started for people logged in. All right, anybody with any questions? Anything about chapter 5? I think, if I'm not mistaken, I think it was one or two people on yesterday said that they could not access the test. I don't know if you're online, but I know with my browser, sometimes for whatever reason, I have to go back and actually install the Proctorio app or whatever back inside of the my web browser. Why I don't know, but sometimes you may have to do that, or maybe I need to reboot your computer and do that, or log out of Canvas and come back in and do it. But it should not ever ask you for a password when you're taking the test. Your Proctorio should be set up, and it automatically goes into the settings that I have, and you're able to take the test. All right. So, like I said, hopefully I cleared up that issue. Um, so chapter 5, we had the programs, we had the assignments, which is the assignments, the quizzes, and whatnot. Um, chapter 6, all right, because like I said, someone completed chapter 5, and we had the test. Chapter 6, it talks about functions. Now, you know that you can, as a programmer, you can write your functions, but then there also are functions that are predefined within the compiler. All right. So it says a function is a module. Well, let me go back and share my screen right quick. I need to exit out of something. Close this up. All right, and share my screen. All right. So I'm in chapter 6. All right. And it tells us about a function. All right. A function is a module. All right. It's and like I say, a module, function, routine, subroutine. All those are the same thing, just got different names. And it's a group of code that someone can run independently of the code to perform a particular task. All right. So it's a function is a module that returns a value back to the to parts of the program that called it. All right. So now we're talking about returning values. So what you can do, you can write code to find out what something equates to or whatever, and then you can return it, whether it's a string, whether it's a int, whether it's a Boolean value, whether it's a float. All right. Most programming languages provide a library of pre-written functions. C++ does that. C++ is a low-level language. Low level meaning that you can write code that will go into the system and affect certain things because it's a low-level language. All right. You don't have as many restrictions in the code, but you can run into issues where those limitations might cause you to have issues in your code. But if you're a good programmer, you can write code to manipulate a system. All right. Um, so it says most programming languages provide a library of pre-written functions. All right. Remember our power function, POW, for in math, the power function take integer value and raise it to a certain power. You don't have to write the code is already written, but you just have to know how to use and the syntax for that function. That's one example. All right. So it says it's pre-written functions to perform commonly needed tasks. Okay. In these libraries, you typically find a function that generates random numbers. All right. So you have a function that can actually allow you to generate random numbers. And like I say, so you can get different numbers as the program is executed. All right. So it says a function is a group of statements that perform a specific task. We know that. Okay. When you want to execute the function, you have to call it. Remember, we have to call it from a function. And the main function would be the first function that calls a function. And then from that, it can be another function can be called from that function, or you can return back to the main and call, another function or that same function. All right. It tells us most or most programming languages come with a library. We said that already. And the functions are known as library functions. They're built in. All you do, you need to know how to use that syntax. All right. And that's why we have to load our header files. So when we need, say for instance, when we do the IO man IP, our main IP and a library function is a library that has what? Set W, set precision, fixed, left, right. So you don't have to go in and try to recreate code for that. Code is already written, to allow you to do a particular task. All right. Talking about the random function, which is a function in C++. And like I say, this allows you to randomize numbers from 1 to 100. One of the downsides to this random function is if you run the program using this random function, every time you run the program, it will start with the same number. But what they've done, like if you wanted an advanced random function, you would take it and add an expression to it. And normally what they would do is they'll take the time and the date and then run an expression on values from that. And because what? Every time you execute a program, you may not run it on the same date, and it definitely wouldn't be that exact same time. So you would get a different generated number each. Well, the smaller the range, well, the more likely you might get the same number. But the larger the range, the more likely you'll get a different number, every time you run that code. All right. So, and this just shows you somewhat how this random function is set up and is somewhat used in a program. So that's the random function. But what we're going to focus on today, we're going to focus on functions that we write, okay? Functions that we write. And like I said, you got the random function, you got the power function, you got many other functions that are used, string length functions that, we didn't use in this class, but they all are functions, all right? If we scroll down, okay, they're just showing you pretty much the flow chart of how that function is being used, written. Now, writing your own function. I think in chapter 3, we wrote, we had two assignments where we wrote our own function. All right. So we'll look at it again, where we can write our own function. Most programming languages allow you to write your own function. When you write a function, you're essentially writing a module that can send back to parts of the program that calls it. You can send back a value. All right. So you're gonna have your function definition, which is your function header. We'll look at that. Followed by the body, all right, and whether or not you're returning any values or not. Okay. Now, if you write a function and there's no data type where you have void, when a experienced program look at that function, they will know that there's nothing to be returned. All right. But when you see int, char, bool, float, string, if you see that in front of the function header that's defining the function, you know that there should be a return value of that data type. All right. So let's look at what the program is talking about, that data type. So if I go to a program, I can mess with this one. All right. So what I'll do, I'll take this program here, or this, and I'll delete all this out. All right. So I'll delete all of this out. Now, I don't know if you remember when we created functions, what we had a prototype. I'll just put a comment up here. We had a function prototype. We had our function definition. The function definition just was the body that told us what it was we are going to be doing in that program. Right? What the program is going to be, what that function is going to be doing. And then we needed our function call. All right, we had to call the function. So, because if without calling the function, you could have your syntax right for your prototype, you could have your syntax right for your definition, but without calling the function, it'll never be executed. Okay, so let's say we wanted to write a function, and this I think we started talking about returning a value. So we want to write a function to where we're adding two numbers, all right, and we want to return the value of the sum of those two numbers. So we want to return, let me just work, let's say we're working with int. So you'll say int, and like it say some values. All right. So that's our function. Now in this function, what I'll do, we're not talking about passing values yet. So what I'll do everything in the call function, and then the call function, and then just output the data, the results in the main function. So in my definition, now it tells me I have an int value that should be returned. There's nothing that I'm passing, all right? No arguments being passed. So I would have to do int some values, no arguments, and then my body. But I know I will have to have like something like return and whatever the variable I'm returning. And I'll just say it'll be sum, just off the top of my head for now. But sum is not defined yet. So in this function, what I can do, if I wanted to read in values, I could say int x, y, or I'll just say num1, num2, and sum. All right. So I have my three variables that I'm using in this function. Then I could do cout. And the first number. All right, cn num1. All right. So see, I'm just writing code, just like if I had just a list, a program that just went 1, 2, 3, each one of my lines of code in my main function. But I've broken down the program into a function. Enter second number, and then cn num2. All right. Now, what? I need to add up my numbers. So what? Sum is equal to what? Num1 plus num2. And so what? This could have been just a program without a function, correct? You know, because all these lines are valid lines of code that can be copied and pasted in the main function, and everything is just done in the main function. All right. But what if you had a program where you were summing something up, you was multiplying, getting a product, getting whatever, or calculate whatever. You may want to write it where you have functions, so you know where if I have an error with my calculations for summation, I'm working in this function. If I have a problem with my product, I'm working in this function. Or if I'm working with some other calculations, I'm in another function. Because what? Just calculating the sum, this could be really 50 lines of code, complex code. But if I had all that information in this one main function, it might make it a little bit harder to debug. Not saying that you can't do it, but it'll just make it a little bit harder to debug. So now, so if you look at this, we gave our prototype, all right? We created our and defined our function, all right? Int some values, no arguments being passed. And then here's my code. I'm reading in one number, reading in another one, summing them up. But then once I get my sum, I'm returning the sum back to the call function. But what? We haven't called the function yet. So to call the function, now I have to assign, I don't have, yeah, I need to assign whatever the return value from the function to a variable in my main function. Because remember, we somewhat talked about scope. All these variables have the scope of this function here. So now if I'm returning an int value, I need to create an int value here so it'll be in the scope of the main. So I could say int, and I could do something like main sum. If I wanted to, I could leave it as sum because the sum in the main scope and the sum in the sum value scope is two different variables. All right. So, and also I could say int results. I'll just say results. Results is equal to, now results going to equal to whatever this function returns. So now all I need to do is what? Sum values, and there were no arguments. And so now what? When I call sum values and it returns back to the main, it's going to return whatever sum is, and it's going to store it into results. And now I can do what? Cout the results is, I could say the sum, I'll just say the results, and I could output results. All right. And now it'll output results. All right. So I've written it this way. So like I said, everything, your main function, and your main function is somewhat clean because what? Oh, what am I doing? I'm calling some values. Whatever this function is doing, if I have it somewhat, how would I say, labeled right with a variable name, I know that I'm doing what? I'm summing some values here. So I'll go here, I sum these values, and then I'm going to return sum back to the to main and store it in results. And now I can print out results. So let's run the program. And I think I have everything pretty much syntax free. Okay. So it's running. What is down here is running. All right. So see here, enter first number. So it everything pretty much worked. And what? It called this function. When it called that function, it output it, well, it declared these variables inside the sum value function. And now it's executing my cout. So enter the first number. Say I put in, say 10, all right? Hit enter. Enter second number. Say I put in 50, well, 25. 10 and 25, that gives us what? 35, correct? So now when I hit enter, it should sum up the values, all right? Num1, 10, plus num2, 25, and store it in the sum, which is 35. And now it's going to return sum, which is 35, back into, all right, whatever this said, I'm storing this into here. So I'm storing 35 into results. And now I can actually print out the variable with results. So I hit enter, and look, the results is 35. All right. Any questions so far? All right. So everybody saw what happened with that return value. All right. 35 was calculated in the sum values function. All right. But it was returned back to the main function into a variable called results. And then we were able to print it out. All right. Now, question. So we have this. If I wanted to output, did that print right? Oh yeah, that's just, well, it done clicked out. If I wanted to print out the sum of, and the first value plus the second value equals results, what would I have to do to my program? Anybody?
Wouldn't you have to pass those values back to the main?
Right. Well, should I pass them? Could I? But you can only pass one value back. All right. But what I could do is I could take this and I can initialize my variables in my main function and then pass them to the function. You understand what I'm saying? Because, right, because I can only return one value back, right? And when I'm passing values, I'm passing it from the call function. I'm passing from here to here, all right? So if I took this here, if I could copy it, I'm gonna cut it. I'm gonna cut this and I'll paste it here. All right. So I'll paste it in the main. Now the scope of num1, num2, and sum is in the main, correct? All right. Well, I can pretty much remove sum because I don't want sum is being returned. So now what I'd have to do is this time well, I have to give them, I think, 0 values because you can't pass something that's empty. All right. All right. So I'm passing them at 0 values here. So now when I call it, I want to pass num1 and num2. All right. All right. But when I do that though, I need to modify my prototype because I'm passing an int and an int. All right. And then I need to modify this to say, well, wait a minute, I'm going to receive what? An int value called num1, which is going to be the scope of this function, and an int value num1. It doesn't have to be, but that's what I'm using in this function. No, oh, not num1. I can't pass it twice. Num2. All right. So now, all right. So you see what has happened here. But now this won't solve the problem because what happens is they still have a different scope. Everybody understand that? The scope of num1 here is for the main function. The scope of num1 here is for, oh, I need to do int sum. I still need my sum. So I need the scope for num1 here is only this function. All right. So this num1 is this. So remember, I think I showed you all this. If you want to pass it, you pass it by reference. All right. And what passing it by reference does, it says that, what happened here? More than one instant overload. How am I going to? That's right. I want to tell you. All right. So now, got it straight. What happened if I'm passing by reference here? I have to tell it that it is a reference reference that's being passed. A reference is the address. When I pass by reference, it tells me that I'm gonna, whatever I do to a variable that's being sent to this function, like num1, I'm passing the address that's stored in the computer. So I'm working with the information at that address. So if I change something or if I pass something, it's using the address. And if I make a change to it, it automatically gonna change it. And we're gonna kind of understand it better as we go through computer science. But what this saying is, I'm using a reference, right? Kind of like somebody using your address rather than your name, all right? So what I said, when they reference your address, any information that they have will be associated to you. Anything they change will be associated to you. As opposed to if it's just your name, it'll be just you. It won't be, oh, excuse me. It won't be the whole household or whatnot. If you kind of understand what I'm talking about. Let me cut this off. Right. It'll be everybody in the household, everything is changed. All right. When you do the reference, if you just do your name, it's just gonna only be for, you specifically. All right. But that's a kind of vague idea. So now with me changing this, having this by reference, I got int num equals 0. But when we read in num here, num1 here, it's going to change num1 to whatever we read in because what? We passed it by reference. So when it says, okay, by reference, go to that address, now I want to put in the value that's inputted, put it in that address for num1. So now, all of a sudden now when we return back here, now I could say the sum of, and then I can do num1, all right? plus and num2, and then I can what did I do on my stream? All right, so I do this, and now what happens? Now I can use those values in my output because they're known in the main function. All right, so now let's debug it again, and let's see what happens. Now those values can be used. So I'll use 23 and 18. That would be what? 8 and 3 is 8, 11, and 43, right? Right. So we hit enter. Well, 41, my fault. So look what happens. The sum of the the num1 value plus the num2 value equals the return value from from that function. All right. Everybody see that? Questions? Now, like I say, sometimes you may want to pass values by reference because you want them to change. Many times when you write functions, though, you may be looking for one particular value. So to do this may create, how would I say it? May create problems when you're trying to debug it. Because what? When I pass by reference, no matter what I do, whether I add one to it, take away from it, divide, whatever, it's gonna change the value. So it just makes it that much harder to keep track. All right. But when you just passing that one value back, now you can say, okay, this value is in this function. I can deal with it. I know what's going on. I'm controlling it from it being changed anywhere else in the program, so you can kind of pinpoint what's going on in what location and whatnot. But like I say, you can use references when you want a value to change, because it might be a value you want to change given if such and such is equal or greater than or not equal, whatever. You may want a value to change. So when you use it in another function, you already have it changed to that value. All right. So it all just depends on how your company wants something coded, how you coding it for whatever reasons and whatnot. All right. Any questions? All right. Now, like I say, this can be complicated, but if you look at the gist of it, you got your function prototype. However you write your prototype, looking at this, int. I know I'm returning an int value. Some value, that's the name of the function. Int, oh, I'm passing an int value when I'm calling it. Let me look at my call. Oh, I'm passing num1. But then what? I'm passing it by reference. So that means what? It can be changed wherever I'm using it in the program, because I'm telling it that it's going to be changed by reference. Same thing here, int, and look, pass by reference. Now, what I'm going to do, I'll take the pass by reference off of the second value. All right. Now watch what happens. And I'm going to take this one off. All right. So now that should correct my problem. Now, so the first one is being passed, num1 is going to be passed by reference. Num2, I'm just passing what? Passing num2 as 0. And then we enter in num2, but num2 is only what? Num2 is local, right? Num2 is only known here, right? The scope of num2, this num2 is only known here. So when I break out, it's going to add num2 to num1 and get a sum. But when I return back here, what? The scope of num2 here is gone. And now I'm going to use this scope. Now, who could tell me what my output is going to be? Say if I put in 10 and 5 for num1 and num2. What would my output?
It's going to be 10 plus 0 equals 15.
Correct. That's right. Everybody understand that. And the reason why the scope of num2 is only in this main, I'm going to pass 0 here, but then what? I'm passing 0 into num2, which only has a scope of the some value. But I'm gonna input 5. When I input 5 here, it's only going to change 5 for this num2, which is what? Local to that function. And then what happens is when I return, num1's already changed. Sum is being sent back in the results, but num2 is back into the scope of the main, where num2 was never changed. Num2 is what? 0. So you're going to get the right output, but then what? Well, I ain't gonna say the right output. You're gonna get the right sum, but you won't get the right what? Output for that label. So let's run it. Okay. So like I say, sometimes you got to be mindful. All right. So if I say 10 and 5, see, 10 plus 0 equal 15. That's not correct. And like I say, the only reason, because we didn't pass the second number by reference, so what? It didn't change it at the address. All right, good job. Like I said, and that's using the reference. All right, that's passing something by reference. So we return the value into results. We passed a value by reference where it was changed and used again, and then we had a local variable, and we passed it into a variable into the call function where it did not change when I returned. All right. So hopefully you understand that part. So let's get back to the notes itself. And like I said, a lot of the stuff we done covered. Function name, we talked about the function name. Return value, we talked about the return value. Whatever your expressions are, whatever, if this is this, do this, whatever, but you're only returning that one value. All right, that one value. Now look here, this is just something showing you. All right. So where the function, you return in what? An integer. So that would be int, the function name, sum, but then what? We have arguments. We have an argument that's going to be passed, which is what? Well, kind of like our program. Num1, and then what? An integer value, num1, and then an integer value, num2. Now we passed them, all right, but then we also passed them by reference. We passed them by value, and then we passed them by reference. All right. But this would be the actual function definition. All right. Let me see if I can bring that down here. So this here, let me see if I can make it move it over and then bring this in. All right. So this, well, minus the reference here. This function definition is equivalent to this. All right. All right. To where but taking away the C out CN. All right. So it's got int, some values, some. Okay, just a different name. But then we got what? Int num1, comma, int num2. So that would be this part here. All right. So we pass in an integer and an integer. All right, into num1 and num2. But then wait a minute, oh here. But then look, if I scroll down here, I got sum is equal to num1 plus num2, and then I'm returning sum. They got result is equal to num1 plus num2, and they're returning result. All right, so same difference. Many times when you're looking at different programs, you're gonna have to kind of visualize similarities rather than try to say, oh, I need to copy this word for word, whatever. No, you look at the similarities, because if you start changing variable names, then you got to start changing them maybe sometimes throughout the whole program. But if you can get that a visual and the concept of what's going on, then you just apply it to what? Your code and what you're doing, all right? And it'll make it much, much easier to what? To modify your program. All right, any questions? Any questions so far? Anybody? Questions?
So the only way to basically pass that value back into the main without doing the references to make it a global variable, right?
Right. And sometimes that can be dangerous.
Yeah.
Not always. Like I say, if you're writing a code, well, it's just dangerous because once you make it global, then you're setting it up to be what? Change where? Anytime in the program, anytime, anywhere. Right?
Looking like on these past three assignments,
Uh-huh.
just did it basically wanted us to do this, but I didn't know how to do it, so I ended up making it a global, made some a global. That way I could get it
Oh,
changed.
that was on the last assignment?
Yeah, the three programs we just did, the do
Okay, so
while,
what I'll do, and like I say, but that's why let me give you an example. Well, that's why I'll be wanting students to work on the programs. Like say you worked on it, you tried to come up with ways, whatever you couldn't. But students don't understand that sometimes, and when I say failing, I'm not saying actually just making an F, but I'm saying in your attempts to accomplish something. Sometimes failing allows you to learn more than just what? Oh, I got it right, I'm finished. You understand? So what I'm gonna and what I ask you to do, I put them out there. A lot of time I put them out there ahead of time. Put them out there until you go at it. And sometimes students like, oh, I see this. Oh, I tried this. Oh, I did this, whatever. Or I researched this, I got this. Because what? You actually pulling things. Then the due date, it closes. And most times I'll like today, well, I'm gonna do it today. I'll say, okay, I'll give you till tonight or tomorrow to go back and modify your code to finish it. So now you done what? You done got your feet wet. You kind of understood what you did. And now you can go back and say, oh, I just need to fix this, do this, do this. Boom, it's done. You understand what I'm saying? But if you don't do anything, it's like, oh, well, I ain't going to do it. I don't know how to do it. I'm whatever. Then when I give you the extra time, you're that much further back. You got what I'm saying?
yeah.
So I'm glad you worked on it. And what I'm gonna do, like I said, I'm gonna give that extra time so that you can work on it and just modify the little things that you say, well, man, oh, I didn't know this. Now I know this, so I'm gonna go back and try this. I'm gonna put this, whatever. And you can make more what? Better make educated guesses on things rather than just trying something, right?
Yeah.
So yeah,
Yeah, I was able to figure out how to get the program to work how you wanted it.
uh-huh.
Like, I feel like this using it like this, passing the reference would have been a better way, to do it.
Right. But like I say, passing by reference, many times you don't want to pass all your values by reference because you don't want them to be changed in that function.
Yeah.
Give me an example. Say we're doing a loan application and we have a function where we calculating maybe the loan payments or whatever. Would you want to pass say the loan amount by reference to that function?
Probably not.
Right, because you the loan amount you don't want it to be what changed at all. So
Yeah.
from that function that the like whatever function you call in the calculations for maybe the loan payments, when you pass the actual loan amount, you want to pass that value and don't have it change. So when you return back, you still referencing or still have what that same value, right? Otherwise, you're setting yourself up to where people can go in and once you pass that loan value by reference, somebody change the loan amount or decrease the loan amount, change and then what? Their loan payments are cheaper, and then they return back. Now somebody just bought something at a lower. They bought it at a low premium, but they still ain't gonna finish paying for it once. You know what I'm saying? By the end of the term. You got me? So stuff like that, that's just an example. There's many other examples, But like I say, certain things you don't want change, all right? But there's sometimes you do want things to be changed, right? You may want something to change given a certain situation, right? Because what you might be passing something like a person's maybe credit score, and then you might, when you pass it to the calculations of the of the person loan payment, that that credit score may change if a person, once you calculated a person's amount of debt to income is different or such and such, then like I say, but I'm saying based on certain scenarios, you'd have to look at the scenario that you find yourself in to determine whether or not you would want to pass it by reference or just pass it so it won't be changed, right? So, like I say, you gotta be wise when you do it. And like I say, sometimes it leaves when you just leave everything open like that to be changed anywhere, you leave your program open for hackers to interject code and make changes at any time. But when you have it kind of like curtailed to where, oh, if they interject code in this function here and they try, like say what we talked about, the total loan amount, all right? If they try to interject code in that call function and you just pass the loan amount by value and they try to change it, then they're gonna get an error. There's gonna be errors in the code. You got what I'm saying? Rather than it being changed and stuff get done. And regardless, right? So that's some of the things that you gotta be mindful of. All right. So, but just remind me at the end of class, I'll give y'all, I guess till tomorrow night to complete the programs, look at them or whatever. Because passing it by reference, passing it by value, if it's global, like I say, you're not worried about anything. You don't even have to pass anything. You can still pass them, but if it's global, it's known everywhere. If it's local, then you have to pass the variable. And like I said, you can pass it, pass the value or pass by reference.
Professor
right?
Sylvester, I had
Yeah.
a question about when you call them functions in like the main body.
Okay.
When you call them in the parentheses, do you have to have just like the exact values that are going to be passed? And what happens if the user has to enter the values? What are you supposed to put in the parentheses for
All
the
right.
body of it?
All right, you talking about like right here where I got int results and then what? Some values and num1 and num2 right here?
Yeah, and then when you call it into the actual main function,
Well,
then
yeah,
you
this is
need
the
to have
main
the
function
actual.
here. Yeah, this is the main
Yeah.
function. And then you got your function definition, right?
Mm-hmm.
And then you got your prototype, correct?
Correct.
All right, so this is how it works. Remember when we first did the program, everything was done in some value and we returned the result. So we didn't pass anything. We did it like, let's see. We did it like this, all right? Now, I'm gonna change it to like this. I'm gonna change it to this, all right? We had this. I'm gonna have to change my output state. We had this, and then we had this over here. Cut. Paste. We just got two of them this time. All right. So now, and what? But look what happens. Oh, I need to take this up. But look, now we can't do this. We can't do num1 and num2 in here. All right. What happens is, and we know that the output, this is what we want to get a result. So you ask, how do I know when to put anything, any arguments in here? So what we're doing here, we declaring our variables in our function. We calculating our sum in our function. and we returning some back to the main function. Some is being returned in the main. So given this program, the way this program is, we're not, when we return our results, we're not printing out num1. We're not worrying about num2. So all we're worrying about is results. So when we ran this program, we calculated everything here. So we didn't have to pass anything because what? Num1, num2, and sum was all defined or declared in this function, all right? And all we wanted to do was return results. Now, what happened is, so like I said, there's no arguments to pass because everything is being done in that function and we're returning just that value. You got that part?
Yes, sir. That makes sense.
All right, we're not returning anything. So, but when we did this, let me take, and I'm just gonna do undo till it get back where I want. All right. Okay. All right. So once we said, okay, now we want to output what was inputted for num1 and what was inputted for num2 to get this phrase here, the sum of whatever plus whatever equals and whatever the results is. Now we declared our variables num1 and num2 in the main, right? So what we said was, in order for it to print out those values, and I took it over, we need to pass those values, these variables, to the main function, but we're gonna pass them by reference, okay? The reference says whatever's done in here to this variable is gonna be done throughout the, for this scope here. Now, I'm gonna show you something. I didn't have to use num1, num2 here. I could have used A and B. All right, and I'm trying to get you to understand what's going on. A here and B. A and B. All right. So now, what happens is, in the main function, num1 is initialized to 0. So when we call some values, we're gonna pass the reference, and I'll leave it blank. The reference of num1, which is its address. So I'm passing the address of num1 and creating a variable with the address of the same thing. Everybody, you understand? At the same address. So when I input a value for A, I'm actually inputting a value for num1 because it's the reference address. Remember I talked about, like, if your home address, if it's your address, it's you. Everything is you. You got me? So it's going to be whatever's for num1 because we said for reference. But num2 is not being referenced, so we passing 0, and 0 is being passed into B. But now we pass this one by value. So B is equal to 0, but then when we say enter num2, enter second number, and we enter, like, say 5, B, the scope of B is only some value. So in some values, B is going to equal a 5, but num2 is still equal to what? 0. All right? So that's the thing. Now, the thing is, maybe they can better answer your question is this. If we had num1 equal to, say, 2, and num2 is equal to whatever, 4. Now, when we pass them, we're actually passing these values. We're not inputting, but now we're saying sum is equal to A plus B, which is what? 2 plus 4. That's going to give us 6 and return it. All right? But still num2 is going to still equal to 0 because we just passed the value. We passed it here. No, num2 going to equal to 4. Yeah. So these are the values. So we gave the values, we passed the values, we returned the sum, and we can still use what? Num1, which is 2, and num2, which is 4. Because what? We didn't input or overwrite anything in the main function, in our call function. Right? So see how there's different ways you can do this, right? But that's why you would do a listing of parameters, of arguments. If you want to say, well, let's say like this. If I told you, and who that was asked that question, Mr. Who?
It was Mr. Morotra, Professor.
All right, Mr. Morocho. If I told you, I wanted you to initialize five test scores in the main function, like say int, and I'll say T1 equals, I'll say T2. If T2 is equal to 100, T3 is equal to 95, T3 is equal to 100, and T4 is equal to 74. All right, so now, given this, if I told you I wanted you to write a function, given this, that will take these values. Now, these are what? Local to, the scope is what? The main function, correct?
Yes, sir.
Right? Now, if I told you I wanted you to take these values and calculate me an average in this function, what would be a way of going about doing it?
You would have to, in the parentheses, put T1, T2, T3.
Right.
List them all out.
Right. So you're taking those values and you passing them to that function so that you can calculate the average. You got what I'm saying? Right.
Yes, sir. So you don't have to put the actual value. Like you don't have to put 92, 100.
No.
Okay.
You can, but then your it's constant. Every time it run that function, it'll be constant. That value gonna be what's being passed, right?
Yeah, because I've seen that in the book. That's what always confused me.
Right.
I wasn't sure.
Right. And I think they showed you that way because they first introducing it to you to say, this number is being passed and this number is being sent and this is what it is. Right. But you can use the variable. And once I put in here, like I say, I have to change this to what? Int, right? Int, right? 5 int. Then here, now I can put my integer values that I'm passing, what? T1. Right? So now I'm passing my value. So now I don't, oh, wait, T4. Oh yeah, I don't have 5. Let's see, I'm a comma.
And then in the body, when you call it, you don't have to include the integer or part of it. It just can be the name of the variable.
It has to be. It has to be. Because what? You already declared them up here. See? It already knows. Even if they were out here, they will be global, right? So it already knows that T1 is what? Integer, right?
Right. Okay.
Now, right. And now I need to go down here and do what? Int.
List them an integer this time. So in the function, you would include the integer.
Right. But in the function, you can give them different names. You got what I'm saying? Because what? The scope of this is different from the scope of this.
Right.
Right. So I could say test1, int, test2, int, test3, int, test4, or 4, int, test5. You got what I'm saying?
Yes, sir. That
Right.
makes a lot of sense too, because when I've seen them change the names in the book, I thought they were doing like a different variable, but it's still the same.
Right. Because
So-
what? I'm gonna get to, when I transfer, when I take whatever T1 here, whatever T1 here is, it's passing it into this variable here. So test one will take on the value of what?
T1,
Which is
92.
correct. There you go.
Okay.
Right. Who had a question? Somebody was gonna say something.
I was just making sure that, so basically whatever order you type it in is how it relates to what you,
Hey, that's an important key. Because remember how when we talked about CN and how we can read in an int, a float, and a char, and if we swap that around, say float, char, int, it can cause issues.
yeah.
Same thing here. When I list this, if I say T1, T2, T3, T4, T5, that's the order list that it should be here. Because what? If I said T1 and then T3, T4, T5, and then T2 here, T2 will take on the value of what? T5. Because it's going to take it in the order in which I told it to send it here. You got me?
Yes.
I'm passing T1, then T2, then T3, then T4, then T5. But then I'm passing it into test 1, then test 2, then test 3, then test 4, then test 5. If these were scrambled up, then we would have to remember how they relate with these. And you got to be mindful of that. You got to be mindful. So everybody understand that. That's very, 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 very important. You cannot mix up the names. Say, oh, well, it knows where I'm going from T1 to T5. No, it does not know that. It's going to take them in the list that is given and put them in the list that is given. Everybody got that?
Yes, sir.
All
Thank
right.
you.
Okay. But did that answer your question about the argument list?
Yes, sir. That makes a lot
Okay.
more sense.
All right. Okay. All right. All right. So like I say, but we went on and we did 5 scores. And then now if we do the 5 scores, we could do an average here and we can calculate an average. If we do AVG, and then we could do something like AVG is equal to just 5. All right, so and that will give our average, and then we can return average, and we get an error on some because we move it, AVG, and then now we could say the test average is no result. Yes. All right. So see here, and that would what? We have test grades given in the main, which is in that scope. We have our list that we passing by value. We passing them into test 1 through test 5. Okay, we created a variable in here called AVG. We calculate our average, stored it into AVG. We return an AVG back to the main, putting it in results. And so now we could print out what the average is. And if we debug it, just to show you, it should run and give, well, let's see what happened. What happened? Redefine multiple, say, include, it's not into what include. Oh, what is it?
You have T3 as 100 and as 95.
Oh yeah, well, but still, that shouldn't make a difference, though. That's not the issue. It's yeah, two T3s trying to have multiple variable names. Yeah, you can't do that because they're in the same what? Same school. Yeah, they're of the same school. And I do the int. Right. So see here, the test average is 92. All right. So and it was integer. So it calculated it. Well, passed them, calculated them, returned the average, printed it out. All right. Okay. And what happens here? If I change average test or what I mean, well, not average, test 1, test 2, test 3 in here, when I return back, it's still gonna equal to what? This, because I passed them by value, right? So I can hold the integrity of my variables here because what? I passed them by value. So if they try to interject whatever, they can do something here. But when we return back, the value won't change. All right, they'll still have their same value. All right. Okay. Any other questions? All right. And like I say, it shows us. Well, it showed us here. Like I say, the sum, and then this was our arguments. Okay, this was our argument list. Int num1, int num2, but we changed it up. All right. This is pseudocode. Here we go. Now, this is what they're explaining to you what happens. All right. Now, when we pass and when we want to return, when we want to actually return something back to a function, but when we pass our values, like I said, when we had int results equal, that's what this would be. This say set total equal to, and it's equal to whatever the return value of this function is. So this function is passing first age, which is 22, into num1. It's passing second age into num2, which is 24. All right. In this function, we say int sum. So what? We passing back, we returning an integer value. All right. So here we declare results. And then what? Results equal num1 plus num2. And then we returning result. And result going to be returned back into total, where you can what? Print out the total. All right. Now, and then this talking about how you flowchart a function. I mean, yeah, a function, to flowchart a function, you wouldn't put begin and end. You would put the actual function header, all right? Whatever that function header is. And notice in this one, some here, excuse me, this says some integer num1, integer num2, but that's what be this. See, this is the function. This is just the call. So int sum, integer num1, integer num2. Then you would go ahead on and create your flowchart just like you would when you did the main. But like I said, you wouldn't put start here. You would put the function name, and you would not put end. You would put return. Now, if you had a value that you were returning, you do return and the variable name or the value that you're returning. If you are not returning anything, you would just simply have return, because what? You have to eventually return back to the function that was called. I mean, the function that called you. Okay, so that's all that is. And this one we return results, so we have to say return results. But if results was printed in the function and we wasn't returning it, we'll just say return, and it'll continue on with the rest of the code when you return back to the main function. All right, all right. Making most of the return. You can read up on that. How to use functions, all right? And like I say, we looked at functions and how they're being used. Let's go down. Input-output charts. These input-output charts allow you to see exactly what it is you're inputting, the data you're inputting, and how that data should look. All right. or description of it, what it should look like. And all this is what? Written documentation of the flow of the program. Because what? Many times what? You write code and you might start writing a program and you might have 15 different variables. But by the time you finish, you're only using 3 or 4 of them, or maybe 5 of them. Because what? You started out trying to do something, but you ended up doing something, saying, okay, well, I could write this expression without having to break it down five or 6 different times. I'll just make it all one complex expression, stuff like that. But for the purpose of documentation, you should always have an input-output chart. It just helps you and even the person that's going to follow behind you, in modifying your program or doing whatever, and it helps you to understand what's going on in the program. Many times we as programmers, we are overlook this and like, okay, yeah, there's something good to do, but I need to get my program running, whatever, But like I say, you practice doing it, it will help, all right? It'll help, all right? So, and like I say, just a way of keeping your program documented, all right? So it says input, there's no input, prompts, the user, again, prompts the user to enter an item or regular cost. What's the output, all right? The item's regular price, okay, and what the data type is real. So it gets you to understand how you're going to output it. Because what? If a price should be in what? Dollar format, right? But when you prompt the user to input it, it may not be in real form, but it has to be converted to real to be printed out, right? And then look, for this variable, discount, or this function at least, with input, an item regular price. So that's going to be what's being inputted for that function. Process is calculating the item's discount by multiplying regular price times the global constant discount percentage. So see, all you're doing is just documenting what you have in the program, where I would say a novice or inexperienced programmer can kind of somewhat read through it and understand it. And given the fact that many times in programming, you may be coding, but you're reporting to a group or an individual that may not have what? Computer skills, right? Might not have programming skills, but you will have to relate the process and what it is you're doing to those individuals so that they can either give the yes or no or question you as to why and how something is being done. All right. So like I said, it's just good practice, to do that. All right. So that's that part. All right. Now, let's see here. Returning a string is just like returning a int, same way. Because what? If I do what? String in the variable name, then what? And then return whatever the string name is, variable name is, it's going to return it back to the function. But in the function, I have to have what? String, whatever is equal to whatever the name of that function. Returning a bool, same thing. Now, remember what I told you. We've done an int and returned the int. In your mind as a computer scientist, you should be able to take what? The int, the float, the bool, the string, and say, well, if I can return an int, I can return a float. I can return a bool. I can return a char by simply what? Putting the data type, and then what? When I get what I want to get, I'll do a return in that char type. So you got to be able to be, and let your mind fluctuate to say, if I can do this with this, I can do it with that. It's just that I got to rewrite it to where I'm using that particular reference variable rather than another one. Because what? It's just like in this program, if I said if I put a float here, then what? All of a sudden now what? I may want this to be what? My return value to be a float. All right, if I can tell you. All right, but then in here, I would want this to be what? Float, right? But what? Return float. You understand what I'm saying? So same thing. Okay, let's see what I done here. Float. What I done? Oh, not float. This should be average because maybe right. Okay, yeah, I got carried away. All right, so you're returning that value, but why this float? That should be right. Some values. Oh, see here, my actual function, my function header. All right, float now. So that should clear it up. So see, I have to, just like I did int, whatever, now I need to do float. If I want to do char, I can do char, whatever. All right. So if I do this now, 0.5, 5.0, then now I should get 94.0. Did I click the right one? All right, let's see, debug it. Oh, it's classic. Ooh, let's see. All right, so see here, 92.2. All right, so see how I got the flow. But now, if I did this though, if I did int here, all right, not int, AVG. I don't know why. If I did int here, and then we go int here, and then I did int here, and then I did int here. Then all of a sudden now it's gonna return that int value, even though it's declared as float. Oh no, thought it was gonna work. Right. See here, even though I declared it as float in this definition here, float, but I'm returning it as an int, it just what? Truncates the remaining part and send it back as int. All right. So that can be done also. Right? And if I change it to char, it would take that 92 and find that char value of 92, and I think it'll be a capital letter. I don't know which one, but it'll be a char value. All right. So you got to be careful when you're returning your values and you're having what data type you're returning. But sometimes you may want to return, like say the 92, the letter that represent 92. All right. Any questions? Any questions? Let's get back here. Okay, that's returning a bool, whatever. But I wanted to get to, okay, that's the power function. We kind of did that and got around. All these are with math functions. Okay, you can look at those. That's math functions, formatting functions. Like I said, we kind of looked at it. String functions. Now, there are built-in string functions, string length, string append, all those. You can do those things. But we're not going to do a program with those, but you can read through that. These are functions that are valid in C++. All right. So I want you to complete the chapter. I'm gonna open up your assignments. Let's see. Why did I do that? I'm gonna open up. Let me go to here. I'm gonna open up your assignments, and I'll open up the test too. But let's see. Go to module. So which was that? That's chapter 5 assignments. Let's see something. What this one was. Well, this was loops. No. Did I tell you use functions? I didn't tell you use functions, right? Right, Clint? Or did
No,
I?
sir, you didn't.
Oh,
I know, sir.
no. So everybody should be straight with these programs, right? I know somebody asked a question about a running total. Oh, that might have been another class. So everybody's straight with these programs, right? So
Yes, sir.
I don't have to open them up. But chapter 6, huh?
It's
Excuse me?
allowed to. It was okay to use a function on it, right?
Yeah. See, you can use a function, and I would say it's to your advantage to use the function because it helps you to understand it better. You know what I'm saying? Right. So I don't frown on that. So now what I'll do, I'll open up 6, 1, and 2. Now look what it tells you. Write a program declaring and initializing two variables, all right, with the values 8 and 2. So I'm telling you what to give the value, all right, variables. Once declared, all right, use a function. Now they global, they're outside the main, right? All right, so that means what? You don't have to pass nothing as arguments, correct? Output the sum and the product of the two values, all right? But I want it calculated and output it within a function. I want you to do that within a function. All right, you call that function from the main function, do your calculations, and then output the results. All right. And make sure you label outputs. I didn't give you what type label to put, so you can be creative or whatever. Make sure you put your spaces or whatever. It say use a function to accomplish this. Declare your variables as global. All right, we should know what global variables are. They're outside of any function. The second one is the exact, I didn't even publish it. The second one is the exact same program, but this one it says, note, locally declare your variables in the main function. So now what happens? Now your variables are in the main, so now what? In order for me to calculate my values in the call function, I need to do what to those values?
Pass them in the
I
argument.
have to pass them. So you see the difference between global and local. So if my variables are local and I'm going to another function, but I want to use those variables, I have to pass them as arguments, right? Pass them as arguments to that function. And in that function, I want you to calculate the same thing, the sum, and I want you to output the data in that function. I don't want you to return anything. We looked at returning whatnot. But I want you to just calculate and print within that call function. Everybody understand that? All right. And what I'll do, I got this, and I'm gonna post a test, all right, for this chapter. All right. Wait. In this chapter, yeah, this is chapter 6. All right. Yeah. So I'll make that available for the 20. Wait. April, today is the 20th. Yeah, okay, yeah, the 26th. All right. Okay. And paste. All right. Then I'll go back to the other one. All right. And then okay, here we go. I'll do the reading. We just went over chapter 6. Oh, class, that's another thing. We just went over chapter 6, right? Oh, I thought
Yes. Yes, sir. Yeah.
all right. So now, what I'm gonna do I could do that next week, because next week is the last week, right?
Yes, sir.
Anybody who owe me a test, well, I'm gonna do it like this. I'm gonna give everybody an extra attempt on the test and the quizzes. All right, that's next week. So if you feel you want to try to make a better grade on a test, or a better grade, or you missed a test, you could go back and take that test or that quiz. Everybody understand that? Only tests and quizzes. I'm not doing no assignments, all right? Tests and quizzes. So anybody have a test or quiz that they either need to make up or they want to go back and try to do better on it, you can do that. I'll open them up next week for you to do, all right? So you can be studying up on your stuff or going back and reviewing or whatnot so that you can hopefully try to pick up your grades and whatnot. All right. And now for the test. Test. Oh, yeah. See, I don't know why. And I will tell you, I don't know why. Sometimes I got to keep on opening up, running this thing here. And sometimes if you get that red, that orange triangle, you may have to go through the add part and add the extension, and then you will be able to take the test. You have to make sure that you do that. All right. If you see that question mark with that orange symbol in it, you will have to. Now watch when I go back. See, when I go back, it should, and I'll do edit. See, it wasn't there this time. So now it got it set up with the proctorial. You see what I'm saying? I don't know why, for whatever reasons, it'll do that. And let me see what this date is. Paste. Right. Okay, that's right. All right. So I have all the tests and the quizzes set up, and the assignments. And next week, like I said, after class, just remind me what I'll do. I'll go ahead on and open up all the tests and quizzes so that you can hopefully make them up. And like I say, you need to start reviewing for your final exam. Don't wait till the week of. Try to get a little head start. All right. So anybody with any questions? Any
No,
questions?
sir. Thank
All
you.
right. All right. See y'all on next class period. And
Have a
take
great
my-
day.
All right. You too.